Welcome to Study Loop.
This is chapter 15, problem number 46. We're given 5 moles of ideal monatomic gas. The initial temperature of this gas is 127 Celsius, and this gas expands and absorbs 1200 joules of heat. So then the heat is positive, right? It's given to the system. And also the system does some work. The amount of this work is 2100 joules. Again, since the gas is expanding, the work it does is going to be positive. And we're asked to calculate the final temperature of this monatomic gas. In order to get there, since we're given the amount of heat that is given to the system and the amount of work that the system does, we actually have an idea about how the internal energy of the system changes. So the change in the internal energy of the system equals to Q minus work done, right? So it's going to be 1200 minus 2100, so it's negative 900 joules, which means the internal energy of the system is decreasing. So then the temperature of the system is also going to change, right? So let's remember the other definition of the internal energy in terms of the number of moles and the heat capacity, right? For a monatomic gas is 3R/2 times delta T. So since we know the left-hand side of this equation and we're giving the information regarding the number of moles that we have, we can get to delta T, which actually consists of this information. It has the final temperature, right? Because delta T means final temperature minus initial temperature. So let's try and divide both sides by N3/2 R. So these are going to cancel. And 3/2 R. So delta T is going to be delta U over N 3/2 R. So delta U is something negative 900 joules divided by 5 moles times 3/2 times 8.315 joules per mole Kelvin. Then the temperature change is going to be fine as something negative because of this negative in front. So it's negative 14.4. Since it's just the change in temperature, well, we're calculating it in Kelvin, but it's going to still remain the same for Celsius, right? Since it's just an interval. Then delta T, the left-hand side, what we calculated, delta T equals to final temperature minus initial, right? And that is negative 14.4 Celsius. Then in order to calculate the final temperature, we need to add initial temperature to this negative 14.4, 127. So then the final temperature is going to be found out to be 112.6 Celsius. So again, the internal energy of the system is decreasing. Therefore, the temperature, you would expect this temperature of the system to decrease as well.